record it if anybody wants to watch it later. All right, so 10.1. What? There we go. So percent is the ratio of some number to 100. So that's just repetition, just to make sure we got it. Number three, I think is yours. Oh, we just talked about it. To multiply, to change the decimal number to a percent, you multiply by 100. Add the percent sign. Remember, multiplying means move the decimal place to the right. Division means move it to the left. We already got that kind of, that's a repetition from the metric system, remember? And then number 5, to compute the percent change. Okay, that's on here too. The percent change is number B. This is the test 2 handout that I handed out last time. So, or 2 times ago. Percent change is this, it's also called percent markup. Percent change is the newer value minus the older value, and then your reference is the older value, so you divide by the older value. So it's the difference between the two, where you subtract the older from the newer, and you divide by the older, and then you change it into a percent. So here, instead of newer and older, they use a current, latest, and previous. So compute the percent change first to determine the difference between the latest, current, and the previous. So it's the old minus the new minus the old, and then divide by the old, which here they're calling previous. Follow? So you can call it newer, older, and older, or latest, previous, previous. It doesn't. It's just a way to describe them. So if you have a positive number, then it's an increase. If you have a negative number, then this one's larger, so you would have a decrease. So the percent change could be positive or negative, depending on the difference. But you always put the newer amount here, the latest amount. Okay, so that's percent change. And then we're just going to go change fractions to percentages, etc., back and forth. So you might need a calculator for this one, unless you know that if 40 goes into 100 2.5 times. So 1/40 is 2.5%. You multiply by that by 2.5, you'd get 26 plus 6.5. You'd get 32.5. So rather than do that in mental arithmetic, once again we just find the decimal, and there it is, 32.5. So that's the decimal. As a percent, I move the decimal place 2 places to the right, and there's my percentage. So 13 parts out of 40 is the same as 32.5 parts out of 100. That's the same ratio. It's the same number, just a different way to express it. Because we're forcing the decimal, or the denominator here to be 100. Because now, X percent, 32.5 parts per 100. You see, if X is 32.5, then the fraction is 32.5 over 100. So it's the ratio of parts per 100, because that's our standard when we want to compare. Because if I say 13 parts per 40 versus 17 parts per 50, what's is larger? If I turn them into percentages, then I have it makes it easier. So that's the reasoning behind percentages. They're for demonstration or comparison, but they're not for computing. Number 11, change this to a decimals, or to a percent, so I move it 2 places. Since I started with a decimal, I don't have to do the division, which is 43.92. So once you get the hang of it. Now, 6.19. Yeah, so it's 619%. People go, what? I go, well, yeah, well.
Having a decimal in the middle.
I know, number 1 is 100%. So if 6 is greater than 1, it has to be greater than 100%. But you get used to it. Let's see, number, 28%, write it as a decimal.
Move the period in the other direction.
Now I just go the other direction, so it's 0.28. Yep. Number 18. Okay, now you gotta be careful, because
you still have to move it over.
yeah, it's 0.0028. Yeah. I don't know why, but a lot of people see that and they go, oh, that's 28%. No, it's 0.28%. See, if you get stuck, well, you can use the calculator, come to think of it.
Calculator.
Oh, can you? No, there's no percent sign on this calculator. But here's what you could do, watch. I could do this, I could do 0.28 divided by 100, because now x is 0.28, you see? I wrote it as a percent, didn't I? But instead of using the percent sign, I wrote per 100.
Right. I like it better on this one.
You got one of those? Okay.
On my phone, I do.
Okay.
What is it, 0.28? Yeah. So if you put the 0.28 and the percent sign, I have my phone.
Sure, whatever.
The calculator on the phone is anyways.
It's not important that you got to have a mechanism to get there and just make sure you're doing it correctly. That's all that counts.
Cool.
I don't care how you do
All
it.
you have to do is know which way move the zeros.
See, now 3/8%. People will go, that's 0.375. No, it's 0.375%. See, we can do that again. Watch. If you're unsure, just use the calculator. See, because it's 0.003375. See, but 0.375 is 3/8.
Right.
But it's percent, so you need 2 more decimal places. So gotta be careful. That's all. Don't rush into it without doing a little bit of thought, because that's what they're trying to do here, is get you to think about, change this to a decimal number. Well, just move it back. No rounding here, so it's 8.079. I hit a period there. You see the period? I missed the enter and hit a period. Oh, I transposed the 7 and the 0. So I'm lucky I had 3 tries.
That's how I feel sometimes too, trust me. I'm like, yes.
That's another reason you get the 3 tries for homework. So you don't get discouraged and go, oh gosh, I gotta be so perfect. 25, let's see what 20. On a serving of a certain brand of yogurt, it has 11 grams of fat. The low-fat version contains 36.25% less. Now, if you take 36.25% as a decimal times 11, that's how much less it is. But they're asking how much fat is in the low-fat yogurt.
So then you have to divide it by the 11, right?
Well, you have to subtract it from the 11.
Right, that's what I mean.
But you could do it in 2 steps, or you can do it this way. You could just say 11 times 1 minus 0.3625, which is the 63.75%. See, now in the parentheses I have 63.75%. I've lost the 36. See, it's less, so less means subtract. So I've subtracted the 36.25%. So it's to the nearest tenth, be 7.0.
Now, why is it minus 1? Because you lost me there. I do it in the.
No, it's not minus 1. It's 1 minus. That's 100%. Now subtracting 36.25%. But I'm saying percent, but I'm writing them as decimals. See, it's 36. It's 36% less. So instead of writing them like that, I'm changing them to decimals.
Oh, okay.
It's still the same number, but I'm not using percents. They're describing it as percents, but I'm using the decimals to calculate.
Yeah, that calculator messed me up to do any
Okay, Listen,
Oh, I
here-
went back to this one.
here's how people would normally do it. They would say, okay, well, how much less is it? So you go 0.625 times 11,
Mhm.
and then you would subtract that. And now here's in the calculator, I'll just go minus 11. I know my
Right.
answer is going to be negative. Oops. Excuse me. I got to start over. 0.3625 times 11. Minus 11, I get the negative because I didn't do it in the correct order, but it's just easier, so I don't have to type things in more than once, unless you make a mistake like I just did. But anyway, there's your 7 grams. You see, they asked us for how much was in the low fat version.
Right.
They're telling us how much less fat there is, so that's what we're taking out, what's left. So 7 grams. All right. And then these are changing percentages to, well, let's see, let's read it. The circle graph has the different classifications of DVDs. So the whole shooting match, there's 1,752. That's your denominator.
Mhm.
And you want to know how many are foreign. So the foreign is 7%. So I think 7% is 1,752. So 0.07 times 1,752. And it says round to the nearest whole number. So obviously 123 would be the nearest one. You see, some people might say, well, it's 122, but I think they'll mark it wrong. See, they want you to be a little more careful with your rounding. They want you to round up. So 123. Because obviously you can't have part of a DVD.
Right.
You can, but you can't use it.
You could try.
You could try. So here's chemical elements that are percentages by weight or mass, whatever, or volume. So it's volume. And the whole container has 75 milliliters. So how much is oxygen? Well, it's 85.84% of 75 milliliters. So I multiplied that decimal, and they want it to 2 decimal places, so I don't have to change anything. 64.38 milliliters. Let's see, 35. Another one of these. Now it's going to go the other way. They're going to ask us for what the percentage is. They give us the numbers. Those numbers add up with that number, 1,950. All 6 categories added together. And they want to know how many are in the alternative. 474. So I just need a fraction. So that's how many are in the category divided by how many total. There's my denominator. And I just got to turn that into a decimal to one place, 24.3. That's pretty straightforward. 30, 40. Population of a country has been increasing for several decades. In 1990, the population was about 226 million. In 2014, the population was 305 million. Determine the percent increase. Okay. Now, I don't have to worry about, what's that?
So you would subtract the 2 numbers, right?
Well, you take the newer one, the latest. So 305. Notice I use parentheses for the entire numerator, and then the older one's 226. The older one's the base, so I want to know what percentage increase is it over to 226. So the difference, and I set it up so that we get a positive. So it's 35.0 actually, one decimal place. So 35%. You can write the 0.0 or not; they don't really care. Okay. So, and I don't have to worry about putting a sign in there, plus or minus, because they say increase. So I know that represents a positive. So I could have subtracted it the other way. I would have got a negative down here, but I wouldn't have worried about that because I would have known that all I'm looking for is the absolute value. So there'll be a couple of these. Okay, now they're going to give us sentences, and we have to form the algebraic equation. If we get lost, we should form an equation, but sometimes it's straight up. What is 14% of 90,000? So that just says X is 14% of 90,000. See, the algebraic equation is the sentence. When you read it, what is, right? What is I don't know, is equals, and it's 14% of 90,000. We could do this one by inspection, watch. 9 times this is 90 plus 36, 126 with 4 zeros, but I only need 2 of them, so it's 12,600. Okay, so you don't have to do that by, I've done it all my life. I've done it all my life, mental arithmetic, so I'm good at it. For 12,600. But that's a statement, algebraic statement from the English statement. If you get lost, that one's straightforward, right? It's pretty straight. If the way it reads, you would not get confused. You would. That's your thought process. So you would just, all you would do is the calculation. And you notice we can't use the 14%. We can't use percent. We have to use decimal. What percent of 88 is 22? Right? X percent of 88 equals 22. So what would I do? I would divide both sides by 88. So X percent is 1/4, so 25%. So X is 25. Right? You agree 22 divided by 88? So 25%. After you see it and you read it, you go, oh yeah, 25%. I automatically think of 1/4. 1/4 of 88 is 22. 51. 25% of what number is 50? So now, 25%. Well, rather than writing 25%, let's just go ahead. See, 25% of what number?
It's behind you.
Thank you. So algebraically, once again, only now the X is the number instead of percent. So we're going to divide 25 by 1/4, which when you invert and multiply, you get 200. You guys think that way? No? I think if 0.25 is 1/4, that way I just invert the 1/4, so the 4 goes up, the numerator, so 4 times 50. The 1 stays down, so that's my denominator. That's how I think.
I never really thought that.
That's just a shortcut when you don't have calculators. But we don't have to. We can use calculators too. I just want to show you that. I guess I'm showing off.
I would have to figure it out on pen and paper.
28 is 40% of what number? That's the same question as this, instead of 20. So it'd be 28 divided by 0.4. So 28 divided by 0.4. 70. And then when you see the answer, you go, oh yeah, because there's 4 7s in 28, there's 10 7s in 70, so 4 out of 10 is 40%. Okay. And then they're going to give you some. I think these are straightforward. A person earns 24,100 this year or 1 year and gets 5% salary. So the easiest way to do this is just to do 1.05. That's the 1 represents 100%, which is this year, and plus 0.05 is the increase. So you can do it with one calculation rather than taking 5% of the previous and adding it, right? That's what we did. This tells us 1 plus 0.05. So this is this year's salary plus a 5% increase times this year's salary. So you just do it all at once. You don't have to do more than one calculation. So 25,305 sounds good. 63. A vacuum cleaner dealership sold 350 units in 2011 and 397 in 2012. Find the percent increase or decrease. Well, remember, you always do the newer one. 397. What did I forget? Parentheses. Order of operations would be violated if I didn't have parentheses. And I divide by the 350 because that's the standard I'm moving away from. So it's an increase of 13.4. So we did one of those earlier. Now they gave us another one. Any questions about that? Okay. 69. A woman purchased a used car for $5,000. She decided to sell the car for 40% above the purchase price. She could not sell the car, so she then reduced her asking price by 40% of what she had increased it to. So it wasn't, see, 40% of 5,000 is less than 40% of what she increased it times 40%. Follow? Yeah. So there's asking, one of the trick one is she'll break even.
Right, because you automatically look at it and you're like, oh, 40 plus 40 minus 40.
Yeah, but that's 40 of 5,000.
Right.
So it's really, you can do this in one watch. Remember how we increased the salary by 5%? Well, I would increase the price by 40%. Oops, I need a point there. 40%. And then I would reduce it by 40%, which means I would multiply it by 60%. See, if I increase it by 40, I add 40 to 100. If I decrease it by 40, I subtract 40 from 100. So those are the two. This is the price that she increased it, right? And she reduces it by 40%. Well, rather than do minus 40% and then subtract it, I just do 100 minus 40% to get 60%. I just do it with. So there's your answer. She loses $800. Well, if you did it in 2 steps, look, you'd have 5,000 times 1.40. And then you say, oh, I'm going to reduce it by 40%. So a lot of people would just go, okay, times 0.4, and then subtract it. So minus 7,000. And then you get your 4,200, which is $800 less than what she originally bought it for. So she's operating at an $800 loss if all those things fell into place for her, as described. Kane's Furniture Store was advertising a table at 6% discount. So the original selling price was $106, and the sale price was $6 or $100. So they reduced it by $6. Was the sale price consistent with the ad? Who wants to answer that? 6% reduction. Something's wrong, isn't it? Well, let's just see. We'll just do this. We'll do 106 times 6%. So it should have been reduced $6.36. So the actual price should have been $99.64. So the sale price was higher than it should have been by 36 cents. The other way to do it would be just do 106 times 94.94. And you can see you're 36 cents too high. It should be that instead of 100. So either way, you can see the 36 is in there. And you know, it depends on how many calculations you want to do to verify that. That's okay, whichever way you want to do it. You've seen these double discounts. They always look like it's a big deal. A coat's marked down 30%, and the customer's given a second discount of 10%. Did they actually get 40%?
No.
No.
10% off whatever the new price is after the 30%.
Right, so it's going to be D. Applying a second discount to a price does not reduce the total cost as much as the sum of the discounts. We're not summing the discounts, no, as a percentages. Okay, so then they're going to ask us for what the true sale price should be for Part B. The regular price is $183.99. So she gets 30% reduction, so that's times 70%, right? And then she gets another 10% reduction, so that's times 10%. Oops. Times 90%. What am I saying? Times 90. So the 0.7 is a 70% reduction. And so there's your first discount. That's your price after the first discount. And then you multiply by 10% less. That's your second reduction. But this way we do everything at once because they want the price. So it's $115.91. Follow? And then they want to know what if you took 40% off, just to show you that it's not really a 40%. So 40% less is 60%. So if you took both discounts at the same time, it'd be $110.40. Oops, 39 cents. 39. So there's a $5, well, almost $5.50 actually, right? A little bit more than $5.50. Okay, so that's it for different mechanisms for percentages. Now we're going to move to this next section, which is section 10.2, and this is personal loans and simple interest. So the first thing we want to do, there's a couple of rules that are important, a couple of definitions, might as well get them out of the way. The money that a bank or other institution, lending institution, is willing to lend you is called what? Or the amount of credit, if you want to call it that. It's called, which one is it? Who knows? Can you see it? Principal, there you go. So that's going to be P. Might as well start writing some of these down. The simple interest formula, I think it's on the sheet also. Some of these are written down for you, but it's okay if I do it again. Right? Yeah. It's between C and D. And E has a simple interest formula. I equals P R T. So P is the principal or present value. R is the annual rate of interest. Notice it's usually written as annual. If it's not, it'll specify it. It'll say monthly or daily or whatever. T is the time in years. These two have the same time. Usually it's years. But if for some reason you get daily interest, then you can use T as days. If you get a monthly interest, you can use, or monthly rate, you can use T in months in this formula, and it'll work out. I'll show you that as we go. And then I is the interest. Or finance charge. That's also another name for it. Sometimes they'll refer to it in the problems as finance charge. And this works both ways. It works for when you save and when you pay. When you pay off a loan or when you put money and get interest from the bank, and then they pay you. And then the future value is A. And A equals P plus I. Whatever you start with plus the interest, that's what you either owe in the future or what you've gained in the future. So A is the future value. Or accumulated value. That's where the A comes from. Accumulated value. I like present value, future value, because then it's obvious. We'll add some more. There's some more that you see on there. We'll add them. We don't need. N's the only. I guess N's the only one that I didn't. N is the number of compoundings, but we won't do that till tomorrow, so we won't have it. Let's see. The money the borrower pays for the use of the lender's money is called the interest or finance charge. Number 5, when using the simple interest formula, time is expressed in the same period as the rate, same time period. And this is another name you'll see for this, by the way, is APR. Annual percentage rate. There's another one that comes up. The heck, it's just going to clear out of my head. But they always advertise it. Oh, APY. So this is the annual percentage rate. We won't do it today, but we'll see something called the APY, which is the annual percentage yield. It's what you would get if you just apply the interest at the end of the year instead of, this goes for compounding. You'll see. And this is always higher than the APR, so the banks advertise this. You know, if you don't know what they're doing, it makes it look like you're getting a higher interest rate. But you do get it if you leave the money in for that total time period, the whole, you know, whatever like for a year, and then you'll get it. But you get your APR applied for however long T is. Well, I guess there is one more, two more we should mention right now, and that's the U.S. rule that interest is always applied prior to partial payment. So, like if you have a loan for 2 months and you want to pay half of it off after a month, half the principal, you have to pay for what the use of the money for the month before you subtract the principal. I mean, algebraically, it doesn't make any difference. Everybody knows that. In other words, you don't get free use of the money just because you're paying off half of it. And then the other one is the banker's rule. The banker's rule says that there's 1 year equals 360 days.
360 days?
Yeah.
I didn't know that.
Because they count it as 1 month and has 30.
Right. Therefore a month has 30.
So there is really 365 days in a bank
Now, there's a reason for that, but it
Well,
doesn't,
that's a
it
simple
doesn't,
way of putting it.
it doesn't count for the longevity of the loan. The reason they do that is because you're going to see R over, no, R over N. Yeah, R over N. You're going to see that formula a lot. Let's say R is 5%. N is the number of compoundings that we do per year, or actually, it's simpler than that. It's R times T, right, in the formula there?
Uh-huh.
So if I say there's 365 days in a year, and I have it for 1 month, then I'm going to ask you, which number is bigger? In terms of 1 month. Which one of these is a bigger number? Is it obvious? The one on the left or the one on the right? Yeah, this is a bigger number. That's why they use 360. It's a few pennies, or dollars or whatever. But since this is a larger number, they have a federal rule. It's in the federal code that bankers use 360 days per year. Now, the longevity of the loan, how many? If you say I'm borrowing it for a month, they'll say which month? Because in January there's 31 days, so you're going to have 31 over 360, right? But that's the reason they do it, is because you get a larger fraction when you put it in for T. Okay, so yeah, okay, here you go. This is the United States rule. If partial payment is made on a loan, the interest is computed on the principal from the first day of the loan until the date of the partial payment. This is known as the United States rule. Number 11. So now we're just going to go ahead and calculate some. It's real simple. I equals PRT. So to start off, these are real simple. Just remember that we have to change the rate to a decimal. So 700 times 0.075, 7.5%, times 30 days. So it's since the R is obviously an annual rate, they said so. Assume that it's an annual rate unless otherwise stated. So that's an annual rate, so I got to turn that into years. So it's 30 divided by 360. It's 1/12 of a year. Because if I put 365, I get a smaller number, and they don't like that. So the interest is $4.38. That's simple. But simple interest is used in all loans. Calculation like on installment loans of the monthly payment. Each month you use this formula to calculate the interest on a monthly basis. So, you'll see that when we get to mortgages. We'll use the same formula, simple interest formula. Okay. Number 13. Same thing. Now this one, you see, it's per day. See, unless otherwise specified, well, there it's specified per day. Okay, now the time T is in months. So I have to line those up, because this is per day, this is in months. So I either turn that into days or I turn that into months per month. So what's the easiest way to do it? So we have 669 is the principal times. Now look, it's 0.043%. So as a decimal, it's 0.00043. And I'm just going to do times 30. I'm going to turn it into a monthly rate. And then I'm going to do times 6, because now T is in months. Now they're both in months.
Right.
I don't need parentheses because it's all the same order of operations. So the interest is $51.78. Now, I could have done it the other way, right? I could have said 669 times the rate was 0.00043, and then turn the months, that'll be 6 months. I turn that into days, right? How do I do that?
I don't know. You know,
Well, how many days per month we say?
there's 30 days.
So that'd be 180 days times 30. See, so I multiply it times 30, whether I multiply it times R or multiply it times T, and I get the same answer. See, the top one I changed the R to monthly, the bottom one I changed the time to days. And it works, it gets the same answer. Because algebra or arithmetically, we're multiplying one of them by 30 to match them up. Make sense? Okay. So you can do it either way. Just understand it doesn't matter. You shouldn't, arithmetically, you get the same amount of money, which is nice. Let's see. Determine the simple interest. Okay, so $533.26 is the principal times 0.071. It's 0.071. It's obviously an annual rate. It says so in the problem. And they give us 97 days. So I got to turn that into years because the rate's an annual, so this is 97 divided by 360. Banker's rule.
Mhm.
So the interest is $10.20. Okay, rolling right along to 17. Determine the simple interest. Okay, so $1,318.02. Okay, these are months, so I'm just going to leave them alone. I don't have to change anything. So R is 0.01 and 2/5 is 4/10. Right? We okay with that? And then times 3 months. So the interest amount is $55.36. So as far as that, look, if I just go 1 plus 2/5, if you get lost, you could just do this. There's your 1.4. That's all I did. I just did it mentally. All right. Number 21. Now they're going to ask us what the principal is, given the other three. So it's just algebra. It's not tricky. If I'm going to solve for any one of the three on the right, I have to divide by the other two. So if I'm going to solve for P, I just divide I by R times T. Just remember, when you write this out for the calculator, you're always best to do this. Because order of operations, if you don't do it this way, you're going to divide by R and then multiply by T. But you want to divide by R times T. So you got to make sure you put parentheses there. Follow? Because these aren't equal. See, here I'm dividing by R and I'm multiplying by T. And all of a sudden, the T's in the numerator. But I want the T to stay in the denominator. So be careful with that. All right, so it's really simple. Just find I, 56, divided by parentheses. R is 0.08. Everything else is the same, and the 6 months. So it's an annual rate of 8%. So I just 6 divided by 12 because it's a half a year. I got to turn it into years. So $1,400 is the principal. And when you get a number with a lot of zeros like that, a whole number, it's nice, right? You go, I got the right number. Let's see if that's right. Yep, I got the right number. Okay. 21, 23. So now we want to solve for T. So it's the same idea. Just replace the T with the P, so you would have I over RP equals T. Because I'm dividing both sides by RP, on that formula. But remember now, once again, don't forget the parentheses. So you always start with I in the numerator, 120.56, divided by parentheses. P is $964.48 times R, which is 0.025. Right? Look at that. A dead on answer. Sometimes they get them like 4.9999999 or 5.000001. So when you round it to the nearest whole number, yeah. So it's 5 years. All right. Good. 25. Okay, a man uses a loan program for small businesses to obtain a loan to help expand his vending machine business. The man borrows $27,000 for 4 years with simple interest of 1.8%. Determine the amount of money the man must repay after 4 years. So this is not an installment loan. He's got the money up front, and somebody's trusting him to give it back with the interest at the end of 4 years. So it's got to be a relative. That's what, if you ask me, it's got to be a rich uncle or
Definitely not a bank.
an ex-wife. Right. Bank wants something. Not only that, they want the collateral, and they want partial payments every month. So, all right. But that notwithstanding, we're just going to treat this like it's a personal loan. So we have P, 27,000 times R, which is 0.018, times T, which is 4. So the man must repay. Well, if you just add the two together, you get 28,944. See, how much he's got to pay back the 27,000 plus the interest. He's paying back the future value, the accumulated value. So 28,944. Yeah, most people don't work this way in the modern world where you can do that. But this is an academic situation, so we'll live with it. Okay. A man borrowed $3,900 from a bank for 6 months. A friend was a co-signer on the man's personal note. The bank collected 4.5% simple interest on the date of maturity. So they're giving him the money for 6 months. How much does the man pay for the use of the money? So they're asking us for the interest first, which is the finance charge. So that's pretty simple. We just solve for I. 3,900 times 4.5%, that's 0.045. And 6 months, so that's 6 divided by 12, half a year. So he would pay $87.75 interest. And how much will he pay back? Just add it to the 3,900, so it's 3,987.75. Luckily, there was 2 zeros there. It was real easy to add. Okay? So this time they split it up into 2 questions. The previous one just asked us for the final payment. Now they're asking us for the interest and the final payment. All right. Okay, now comes a real strange type of loan. It's called a discounted loan. It's kind of misleading because it doesn't. I think these have been outlawed in most places. What happens is you pay the interest up front by deducting it from the loan, from the principal. So they adjust your principal by subtracting the interest. They call that a discounted loan. Because then when you pay it back, you don't have to pay the interest. You already paid it. You just pay back the total principal.
And this is something you see around here, probably like nowadays. Discounted. I've never even heard of it either.
They used to do these a lot because it sounded real good for people.
Yeah, of course.
But I'll show you. We'll show you the fallacy of them. That's probably why they've been outlawed. So we start the same way. We just figure out the simple interest. That's always has to be calculated straight up. So it's 6.5%. It's 8 months, so that's times 8 divided by 12 because everything's in years. So the interest is $288.17. What they do is they subtract that from the principal. So the amount of money that Joe received, so you would take 6650 minus the 288.17. That's why they call it a discount, because they're discounting the interest. It's like, oh, you already prepaid it. You don't have to pay any money, right?
Well, you have to pay the loan back. So.
Yeah, you pay the principal back, so you pay that much in excess of what you took home. So you're just paying, it's discounted, you're paying, it looks like what you're borrowing, but that's what you're actually paying back. You're actually paying back the 6650. Because you're only taking home 6361.83. Now the question is, what's the actual rate of interest? So we know what the interest is. It's 288.17, right? And we're going to divide that by P times T. But which P do we put in? And we don't put in the 6650 because you didn't take that home. You took home 6361.83, and the rate, or the time was 6 months, 8 months. So 8 divided by 12. And this will give us the true rate. You see, it's 6.79%. It's not 6.5%. So the actual rate was 6.79%. Almost 7%.
So you actually paid more.
Yeah, you paid a higher percentage because you have, for the same amount of interest, you got less principal. So, right, if you apply that like we did to the principal you took home, by definition, that's the principal, right? And so you have a higher interest rate. But they used to make it sound like, oh yeah, we'll give you a little bit less, but then you have to pay back less. It sounds good, but they're making a few bucks off of it.
Yeah.
They're making a higher percentage. But you know, most consumers wouldn't know that, beans from buttons, right? Okay, here's a couple of, this is an example of what we call usury. You know what usury is, right? Beating people over the head, you know, getting large rates of return, you know, like 100%. So now, on the face of it, it seems harmless. Elisa needs money to repair her home air conditioner, so she pawns her bicycle. The pawnbroker gives Elisa $270 for the bicycle. 10 days later, she gets her bicycle back by paying $279. So for $9 over 10 days, she got to use the $270 to repair the air conditioner. She got her paycheck. Now she pays him back $279. What's the annual interest rate? So this is how we do it, right? How much interest was it?
It was
$9.
$9. And we divide by P, which is 270, times T, which was what? 10 days?
Mm-hmm.
So we got to turn that into years. 10 divided by 360. It's 120%. On an annual basis. She paid $9 for 10 days, right? There's 36 10-day periods in a year. 9 times 36, 324. That's 20% higher than what she was loaned, right? Because if I take 324 minus 270 and divide by 270, I should get 20%. See?
That was hardly an offer.
Yeah, but she doesn't care. The way she looks at it, it cost her $9 because she needed it. Yeah.
Which one had a bicycle? You think a bicycle for $200 in one shop?
No, but
I know, she should.
might have been electric then.
There you go, there you go.
I have one.
Yeah? My kids have one, I've never been on it.
It flies.
Yeah, I might have to have some fun with it. I'm so afraid I'm gonna.
Mine gets up to 25, 26 miles an hour.
Wow. See, that's pretty quick.
Yeah, it is.
Wow.
It is.
Yeah,
What's nice about it is when I need to go, I don't have to you don't have to get up and you have to get that first pump.
Yeah.
I just hit my throttle and I'm gone.
Nice.
I mean, I don't have to go real fast, but I just got to get moving. I don't lose my balance, but the traffic's too nuts. I don't use it out there too much.
Well, did you see, there was a huge accident last night. We were dropping my son off on the boulevard.
Use a bicycle?
And Lehigh, over by the Walmart that's there. So it was a horrible accident. I guess, and it happens a lot there because people are just jaywalking across that road and they shouldn't be. So it looks like a guy on a bicycle was crossing the road and the motorcycle didn't see him, hit him. They both fell and some SUV came by and ran over the guy in the front from the bike, killing him on the spot and ran off. It was a hit and run. Oh my God. 83-year-old man. The other guy was a young guy on a motorcycle was in critical condition at the hospital.
Yeah, happens too fast.
Yeah.
All right, so that was usury. I think there's another one coming up later, but now we're going to do this number of days. So you have the sheet. You can also, if you're using these online, they give you the sheet, except it covers everything up. So now the one thing you have to look for here is you always got to make sure whether it's a leap year or not. So make sure you don't overlook that. This one's not a leap year, because in a leap year you can see that I would have to add this February 29th, which means from March 1st all the way on I have to add one number, because December 31 would be 366 days for that year. So when it's a leap year, you have to make an adjustment. There might be one or two problems where that occurs. For the most part, when we get to some of the loans coming up, they won't do that. But always make sure you know. So we want to go from March 12th to September 7th. So find November 7th first. I said September. November 7th is number 311, right? And then now you find the second one, which is March 12th. And that is 71. So you subtract 71. So 240 days. Now notice we don't count March 12th, because you don't count the first day that you got the loan. You didn't really use it until the end of that day. So you don't count that day, because you're subtracting this minus this. So it automatically works out. So 240 days. All right?
So if it was a leap year, you would just add one more date in there and make it 241, is that or?
Well, not for this one, because they're both after February 29th. You know, whether it's a leap year or not, you don't have to worry.
No, but I meant
If the only time you have to worry about it is if the February 29th comes between your two dates.
Okay.
I mean, if it was a leap year, then it would have been 312 minus 72. It still would have been 240 days, because they both happened after February. So you would add one to both of them, but so it doesn't really matter. The only time it matters for a leap year is when February 29th is between the two dates.
Okay.
Somehow. $35. How many days from February 13th to October 20th? So October 20th is, I'm going to go ahead and use my handout. 293. And February 13th, oh, it is a leap year.
It says it's a leap year on that one.
Yeah, so this is 294. But February 13th comes before, so that remains as 44. Follow? It doesn't come after the 29th, so it can't. So this is one where February 29th is between them. But the only one that gets added is the one that's after February 29th.
Okay.
So 250 days. So that would be the length of the loan, 250 days. If you initiated the loan on the February 13th and it matured on October 20th. Let's see, that was 35. I think there's a couple more of these. 37. How many days between August 21st and May 24th? It's not a leap year. So this one goes around the corner. So this one you calculate a little differently. You start with 365. You want to see how many days are in the first year. So then you subtract August 21st. So August 21st is 233. So that's how many days are in the first year, from August 21st to December 31st. And then you just have to add on how many days are in the second year, going from January 1 to May 24th. That one, so now you're just going to add 132 plus 144. Both agree? So there's 276 days total. So this one you have to split it up with the two calculations. Follow?
Mm-hmm.
See, I got to go from August 21st to December 31st, and then from January 1st to May 24th. But that's easy. Once I get the first part, all I got to do is add the number for that date in the year. Okay, that was, let's see, there was another peculiar. Okay, now they're going to tell us how many days. So it doesn't matter if it's a leap year or not because it's after February. So it's 4 months later, it's 120 days. So April 22nd, I have to find that number. April 22nd, 112. So if you take 112 and you add 120, that's day 232. So then find that, and it's August 20. So you hit August and put in a 20. All right? And then one more of these, 41. Determine the due date of the loan using the exact time if the loan is good. It's in a leap year, from November 12th for 210 days. So this is about as difficult as they get. All right. So first of all, November 12th is what day? 316. So I take 365 minus 312. So that's 53, and I subtract that from 210.
Why 312?
Because that's November 12th.
No.
Oh, 316, my bad. Okay, let me just start over. 365 minus 316. I don't know where I got the 12 from.
Because you were reading November 12th.
Okay, so that's 49 days in the first year, and now I need how many more days? In the next year, I need 161 days. See, I just did the subtraction backwards, if that's okay. So I need 161 days, but it's a leap year. So you have to add,
One more day, right?
so you have to go back to day 160 in here. Because that becomes day 161 in the leap year. So what's 160? June the 9th.
July 9th.
Is it July or June? June.
I'm sorry.
So it's June 9th. You see how I said that? I need 161, but it's a leap year, so I have to use June 9th because it would be 161 if it was a leap year. Follow? Okay. So I'm not sure how difficult this will be. They're pretty much, we're going to do some examples here. We don't have to worry about leap years, which is nice. Okay. So now we're going to do what we call partial payments. And it's all involves using simple interest formula at least twice. So let me show you what I mean. Now the first thing I do here is I get the maturity dates. So I start with the second one, May 1st, which is day 121. And I subtract February 1st, the effective date, which is day 32. It's not a leap year, so I don't have to worry. So the first partial payment will come after 89 days on May 1st. And then the second payment is due August 31st, so that is day 243, and I subtract May 1st, which was day 121. So the second partial payment is 122 days. Okay, so once I know those, now I can figure out everything, because now it's easier to get that done first and get them out of the way. So you got 89 and 122. Any questions about that? We good? Okay, so now I want to figure out the first interest due at May 1st. So I take the original principal, 2,200, times the rate, which is 6.5%, times the 89, which is the amount of time, divided by 360. So there's my PRT for the first payment. So I will need to pay interest of $35.35. So I take 2,200 and I add 35.35, which I can do with one operation here. And I subtract the 1,000. See. So that's the principal that's left for the remainder of the loan. It's the original principal plus the interest minus the partial payment. So you can see that if I subtract 1,000 from 2,200, I get 1,200, but I have accrued $35.35 interest. But now they can only apply interest to that amount. You see? Because that's what's left. So now I take the 1235.35 times the 0.065% times the 122 divided by 360. Because that's how much time is for the second installment. And I hit enter. There's my remaining interest. So I take my second principal, 1235.35, and I add the 27.21. And there's my final payment, 1262.56. So guess what? The 62.56 is the total amount of interest that finance charge that I accrued, because I paid 1,000 and now I'm paying 1,200. My 2,200 was paid back in 2 installments, but I had to pay the 62.56 interest. So 1262.56. So do you need more details on that, or can you see what I did?
I can see what you did.
Let me show you in a flow chart kind of idea. You could put subscript on it. You could say P1 times R times T1 equals I1, the first interest. And then you take P1 plus I1, and you subtract the first installment, which in our case was 1,000, and that gives you P2. So then you take P2 times R times T2. This was 88 or 89. This was 122, and that gives you I2. And then you just take P2 plus I2, and that's your final payment. That's all we did. But I calculated these ahead of time, because I know this, it's given, and this doesn't change, R doesn't change. And once I do the first I, then you see what I did. I add the interest. Now, algebraically I do it this way because it's the US rule, but it doesn't matter which one you do first, as long as you do include that. I mean, you can subtract 1,000, but you still have to add the interest. You don't get the free use of the money for 89 days. You got to input. But you don't have to pay interest on the 1,000. It's gone, right? So your interest rate is applied to a smaller principal. And you can see that's all I did. You can see if you follow along, these are the numbers that fit in. You know, I took a shortcut here. I did the 1,200 plus the 3535. I just added them together because there was 2 zeros there, so I took advantage of that. Okay? Okay, we'll do another one of these. Let's see, number 47. Okay, so once again, I'm going to do the maturity dates first. So, I start with the middle one, December 12th, and this one is not a leap year. So December 12th is day 346. Did you find the 346? Then I do July 15th. That's the effective date. 196. 196. So the first period is 150 days. And then I do the maturity date. Now this one's kind of a screwball in a little way, but well, not really. I got to go around the corner. So I do 365 minus 346. So there's 19 days left in that year, and then I add February 1st, which is 32. So the second period is 51 days. So the first installment is paid after 150 days, and the final payment comes after another 51 days. So the total for the loan is 201 days, if it matters. All right, so I can clear that. I'll start with the original principal of $7 grand. The interest rate is 6%, and the first one was 150 days, so that's times 150 divided by 360. So the first interest is 175, which I add to the 7,000, so that's 7,175, and I subtract the first installment of 4,000. So my second principal is 3,175. This is nice. There's no pennies, isn't it? Mm-hmm. So now I got to calculate my second interest. So that's 3,175 is my second principal. You see, if you subtract 4,000 from 7,000, that gives you 3,000, but you have to add the 175 interest. So I have my 375 times my 6%, and now this time it's 51 days. I got to turn it into years, so I divide by 360. So my final interest is $26.99. So I take the 3,175 and I add the $26.99. So my final payment is $3,201.99. So $3,201.99. Not too fast, or get the idea, right? All right, so now we're going to do 3 of them. 2 partial payments and a final payment. So now we have to have three dates. Sometimes they set these up, they're really nice and straightforward. Let's see, 49. So you see I got 2 partial payments of $400, and then a final payment. And they're all the first of the month. So this one's easy. Look, if I go from October 1st, September 1st, that's all the days in September. So the first installment is 30 days. Isn't that nice? Right? Isn't that nice? I love it. So the first one's 30. The second one goes from October 1st to November 1st, so that's all the days in October, that's 31. And then we go to December 1st, from November 1st to December 1st, that's the final, is 30 days. So they're each at the beginning of a month. So 30, 31, 30. This is September, October, November. Right? We don't need to calculate numbers, it's straight up.
Right.
Okay, good. Everybody okay with that? Mm-hmm. All right, so then I go to my original principal of 1,900. I multiply by, the big percent, 15%. Woo-wee, times 30 divided by 360. So that's 1923.75. That's the principal plus the interest, and I subtract the first installment of 400. So that's my second principal. So I take 1523.75 times 15%, and now it's 31 days. 31 divided by 360. see what I mean about the banker's rule? They don't give you 30 days for each month. Whatever days there are, they actually,
Right.
yeah, so it doesn't work both ways. So my second interest is 1968. So I take my principal of 1523.75 and I add 1968. And I subtract 400 again. This time I couldn't do the addition seamlessly. I had to actually, see on the first one it was real easy, 2375 with the 2 zeros. So my final principal is 1143.43 times 15%, and once again it's 30 days. So 30 divided by 360. So my final interest is 1429. So I take the 1143.43 and I add 1429. So my final payment's $1,157.72. It's harrowing when I get a mistake. I've had this where I get a mistake and I go, okay, now we got to go back and find my mistake. But you see the process. All we've done is add a third line there we go from P2 to P3, right? Okay. Okay, I'll do one more unless you don't want me to.
Yes, please.
All right. 51. Once again, it's two partials and a final. And August 1st and July 1st. So that's 1 month. That's a month of July. So the first one's 31. That's easy. The second one goes from August 1st to September 15th. 45? You sure?
No,
46.
There's 31.
Because August has 31 days.
Okay.
So it's 46.
I say, how dare I?
Now, the last one's October 1st, so that's the 15 more days in September.
Right.
So the last one's 15. All right? You guys are good. You don't have to do all the subtractions. So we start with 11,300 times 6%. And we said the first one was 31 days. $58.38. So that's 11,358.38 minus 5,000. So there's my second principal, 6,358.38 times 6% times 46 days. 46 divided by 360. There's my second interest of $48.75. So I take the 6358.38 and I add the 48.75 and I subtract the second partial, which is 2,000. So my last principal is there, 4407.13 times 6% times the last one was 15 days. Thank you, 15 days. Should be a small amount of interest. Yeah, $11.02. So I take the 4407.13 and I add 1102, right?
Mm-hmm.
And I get 44.18 and 15 cents. Let's see if we made it correct. See, we got a mistake. I hope it wasn't the number of days.
I didn't get to read what it said.
Oh.
It said something about the US.
Oops. Oh man, now I really screwed up. I'm sorry, but I lost the whole problem.
It's okay.
We'll go to your new one.
Let's see if I can get it. We can do it again if you want. It's got different numbers.
Yeah,
Oh, but it has very similar dates.
yeah.
It's just different, but the same dates. Let's double check the dates. Let's see if maybe we were too fast on it. Let's double check them. What the heck? So if I take, August 1st is 213, and July 1st is 182, 31. If I take September 15th, 258, minus 213, 45. She was right. That was the problem. See, just a slight problem. You didn't want to insist on it, did you?
Mm-mm.
We overruled you, didn't we?
Yes, you did.
Let's see. Let's reason this out. August has 31.
But well, we're counting August 1st, so wouldn't we be counting 30 days and not the 31?
That's right. That's right.
Oh, yeah, I felt for a second.
Well, then we found our mistake.
Mhm.
And then October 1st, then the last one's 15. We'll double check it. October 1st is 274. So maybe it's a good idea to go ahead and do these slowly so that you don't. Oh, that one's 16 days.
No?
Yep.
But then it should have given the same.
No, because you have different principles.
Oh,
The days would have been the same, but the
the
principle.
principles would have been different.
Yeah, see, we use this one less day, and we use this one more day. So
So we have to pay attention to the calendar.
I'm not sure how that happens, but it does.
Okay.
I'm glad you figured that out here, instead of at home where I'd be
Yes.
frustrated.
Yeah, and I threw
I'm
my
probably
laptop.
throwing my computer.
So maybe it's a good idea to go ahead and use the numbers.
Yeah, that's what we just said, we have a calendar right there in front of us.
Might as well use it. I don't know why. Okay, so let's go ahead and do this. 31, 45, 16. We'll go ahead and do this. All right, so I do 10,500 times, this is 8%, times 31 divided by 360. So that's $10,572.33 minus 1,000. All right, so now we have $9,572.33.
You want one extra 5 in there?
Thank you. Times 6%,
8%.
8%. Thank you. 45 divided by, oh shucks, hit the wrong key.
I think we're all getting tired.
Yeah. Past my bedtime. No.
I've been up since 4:30.
It feels like it's past night.
Yeah, it really does.
All right, so I got 9572.33 plus. This is I wonder how these numbers worked out. 9572. Isn't that amazing?
That is crazy.
And then I subtract 2,000. Oops. I put 20,000 in there.
Mm.
So there's my last principle, 7668.05 times 8% times 16 divided by 360. We said 15. We had them both. We had them backwards.
We put days, one day in one and took out.
Yeah, and it makes a difference. Probably not a lot, but the bank, for their records, they would probably be pretty angry about it.
And plus for us, it's, the test. You get it wrong, you get it wrong.
10, no, that can't be right. 7, I'm missing a decimal point. 2726, I put 22,000.
Yep.
7, 695, 31 cents.
Ooh, yay.
All right, so it was the day thing.
Mhm.
It would seem trivial, but you can see that it's pretty important. Okay, one more for, illustration of usury again. I mean, on the face of it, it seems almost, Joaquin pawns his favorite watch for a loan of $120. After 30 days, he pays back $200. What's his, what interest rate did the pawnbroker charge? Well, he paid $20 on 120. That's 16% for a month times 12. It's 200%.
Wow.
Let's see if that's right. Let's see if that's right. So, we need I, which is $20, divided by P, which is 120, times T, which is 30, divided by 360, 112, 1 month. Yep, 200%. Now, it sounds kind of reasonable. Okay, you loaned me the 100. I paid you $20 for using $120 for a month.
It doesn't sound that bad.
Doesn't sound that bad, but when you put it in terms of percent, you can see it.
Yeah, 200%.
200%. On a you know, amortized on a yearly basis, that's a lot. All right, so you guys are geared up for homework 6 and also test number 2. So we'll start homework 7, test number 3 material tomorrow. It'll be, things are more concise now as we go forward. It's all money. We have a good head start with this simple interest.
Okay.
All right. Any questions?
Sure.
All right. Travel safe. See you tomorrow.
Thank you, you too. See you tomorrow. I'll be happy by the time I get here tomorrow. Tax deadline is over.
I thought it was tomorrow.
So by the time I get here tomorrow.
Oh, that's right. It'll be done. I got it.
I'll be a happy little camper.
Your headaches will be done.
Yes. You can sleep better at night.
I guess when they come in after tomorrow, they can beg all they want.
Exactly. It's more just, oh, I got a letter from the IRS. Oh, I just need to, do my paperwork from my extension. I got you on all that. But this last week, I have never met so many nasty people in my life.
Boy.
It's incredible.
Money changes people. Like, you can be the sweetest person in the world, money will mess with you.
Oh, I know families. It almost destroyed my family.
Yes.
When my parents died.
Oh, yeah.
That happens a lot.
It does. Like, people go crazy. Like, no.
But once you do get the house.
Exactly. Yeah, that's not cool. I already told my kids I will have a will. Like, no. Have a great night, Dr. Shay.
Likewise.
Yeah.
Yep.
Exactly.
No, how I'm gonna do it.